Technology surrounds us, it's everywhere. And when we use any kind of technology, we want to know that what we're using is both safe and secure. And if not, then we get things like the Ariane 5 disaster, where a rocket exploded, costing millions of dollars due to a small software bug. So how can we find these bugs? Well, we can test. We can give a software a particular input and check for a particular output. And we could keep on going, and maybe we find an input that produces a bad output. But what we actually want to check is, for all x, does a particular bad output occur? Or does there exist an x such that this bad behavior happens? To do that, we can convert these software into a mathematical quantified formula. This is a formula involving these for all and exist symbols. And then we can convert that formula into an unquantified version. And this will tell us exactly where the good and bad behavior of the algorithm happens. So how can we do this? We can use a tool called Cylindrical Algebraic Decomposition. This takes a set of equations and decomposes space according to their behavior. We can use CAD to convert these quantified formula into unquantified versions. But CAD algorithms generally just use a collection of polynomials, whereas these polynomials have come from much more structured, larger formulae. To use this structure, we created a new idea called Truth Table Invariant CAD. And this uses this structure to create much smaller output. So if you want to analyze a formula and see where it's valid, shown in green, then a TTI CAD produces a much simpler output. We can also trim our output and produce what's known as a sub-CAD. And these sub-CADs come in a variety of flavors that can be combined together to become even more powerful. We can also precondition our input by either passing it through other algorithms or reformulating our problem. So we have all these ideas, but it's tricky to know how to use them all. So we're developing a tool called CAD Assistant that uses theory, metrics, heuristics, and machine learning to help predict the best way to use CAD for a given problem. This CAD Assistant lets us use all of these advances without knowing the underlying theory. And this means problems like moving a ladder through a corridor that were previously infeasible can now be tackled through CAD. So what does this mean? It means that we're creating smaller, faster, and easier CADs. This means more applications, and hopefully it means safer technology for all of us.